So students, now there might be some questions. Okay, very few of this kind will be coming. Okay, but still, just I'm discussing it for you. They will be giving you some numbers. Okay, and they will be asking you whether these are irrational numbers or rational numbers. Okay, so I've taken a small question. So which is this? Suppose like these numbers are given and you are asked to check whether they are irrational number or not, means whether they are irrational number or rational number. So the numbers are 7 root 5, 7 by root 5, 21 plus root 2, pi minus 2. So we need to take note of some of the components of this number, some of the coefficients of this number. Okay, so suppose the very first number, which is 7 root 5, here you see root 5. So any root of a non-perfect square number is an irrational number. Okay, and it is not necessary that root of non-perfect square number will be irrational number. That the value of root has to be non-terminating and non-recurring, then only they will be irrational number. So let's check the values. Let's talk about root 5. So root 5 value is 2.236 dot 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 dot, right? So it means that you see that this is a non-recurring. The same set of digits are not repeating itself, so it's a non-recurring one. And also this is non-terminating, this root 5. So root 5 is an irrational number. Okay, and whereas this 7 is a rational number. Any rational number which is multiplied with an irrational number will be giving you an irrational number only, because root 5 value is this. 7 root 5 will be, you just multiply 7 with it, so you are getting this value. Okay, and this goes on. So this is also becoming a non-terminating and non-recurring decimal, so this is also irrational number. Okay, let's talk about the very next one, 7 by root 5. So root 5, we saw that it is an irrational number. Okay, so if you divide a rational number by an irrational number, so ultimately the result will be an irrational number only. So this is also an irrational number. This is irrational, this is also irrational. Okay, let's talk about the very next question, which is 21 plus root 2. Now this root 2, you see root 2 is 1.4142 dot 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 dot, and it goes on, right? So this is also an irrational number, where this is a non-terminating one and it's a non-recurring, right? So 21 plus root 2 will become something like 22.4142, and it still goes on. So this is non-terminating, non-recurring. Again, I'm repeating, non-terminating, non-recurring. These are the only two properties of irrational number. Okay, so this is also an irrational number, same irrational number. Okay, let's talk about pi. There are direct questions which might be coming into exam. Is pi a rational number or an irrational number? Okay, so the pi value is 3.1415 dot 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 dot, and it goes on. So again, here you won't see any set of digits which are repeating itself. You won't see it terminating, so this is non-terminating, and since the digit are not repeating itself, so it's non-recurring also in nature. So pi is an irrational number. Since pi is an irrational number, so pi minus 2 will be 1.1415 dot 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 dot. So this is also a non-terminating and a non-recurring decimal, so this is also irrational number. Okay students, so these all four values, four numbers over here, these are all irrational numbers. So non-terminating these are, and they are non-recurring decimals, so these are the irrational numbers. Now we will be moving on operations on irrational number. So students, before we start this operations on irrational number, I would like you people to do some homework. Okay, so we call them as the law of radicals. We call them as the law of radicals. there are few laws, okay? If these laws of radical are learnt properly, then you won't have any problem in solving these kind of simplification question. Suppose let's uh, let's zip through them. Suppose there is a number, okay, which is having some power, and this is multiplied with, not this, as a whole it is multiplied with another number but having the same power. You see, means suppose the number is same, the number is a, it's a mistake, it's a printing mistake, students, please don't mind. This value is q, so these are called as base. Okay, let's talk about this a power b. This a will be called as base, this b will be called as exponent. So here the bases are same, just the exponents are different. So whenever two numbers, okay, which are same are multiplied and have different powers, so what will happen, the number will be there and just the powers will be added. So let's talk about 3 power 2 multiplied by 3 power 5. So this will yield you 3, base will be same, just the powers will be added, 2 plus 5. So that value is 3 power 7. Okay, understood? So now the very next one, what is here? A number is there, it is having a power. To the whole there is one another power. So what happens? These two powers will get multiplied with each other and then you will yield this. Suppose 5 square is there and then whole power 5 is there. So what will be there? What will be there? This 5 will be there as it is. 2 into 5 it will become 10. Okay, so 5 power 10 will be the answer. Suppose there are two numbers, okay, which are same and they are divided having different powers, then their powers will be subtracted. It is the same over here. Two same numbers having different powers are multiplied, okay, having different powers are multiplied but the numbers are same, means the bases are same. So what will be there? Nothing will happen, just the power will be added. Here two numbers are divided, okay, same numbers but the powers are different, so the powers will be subtracted. So if two number with same power, same bases, two numbers which are same, they are multiplied and they are having different exponent, okay, so their exponents will be added. Two numbers which are divided to each other, being divided, so and their exponents are different, numbers are same, so just the exponent will be subtracted, nothing else. So let's talk about this. Suppose this is 6 power 8 divided by 6 power 3. So this will give you 6 power 8 minus 3. This will give you 6 power 5. Okay. Suppose you found two numbers in the fourth one. You found two numbers are there. Okay. These two numbers are there. They are different numbers, but their powers are same. So what will happen? The numbers will be multiplied to each other, and it will have the same power. Suppose 3 power 5 into 4 power 5 is there. What will happen? 3 into 4 it will become 12, means 3 into 4 and the power will be same 5. So this gives you 12 power 5. So having explained all this, we will be now moving on questions, okay, where we will be using all these four kind of radicals. Okay, students, before we move on to the applications, means the operations on real numbers, okay, just need to zip through this once. Okay, there's a very small concept known as surd. Okay, so what is a surd actually? Suppose there is a value suppose this 6. We all know that your 6 is a rational number, right? Now suppose to it there is fifth root, or 6 is there, there's a 3 root, cube root, right? If the value of this fifth root of 6 is non-terminating, non-recurring, and the value of this cube root of 6 is same, means same of the same nature, non-terminating and non-recurring, then this is called as a surd. Then this entire number is called as a surd. So suppose this value is got, I'm just just approximating 1.379856 dot 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 dot, okay, and your 3 root 6 came out to be cube root 6 1.3897654 dot 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 dot. There are too many numbers, okay. So this non-terminating they are, and they are non-recurring in nature, right? So what I'll call is, I'll say that fifth root of 6 and cube root of 6 are surd. They are called as surd. So as we discussed this, suppose this fifth root of 6, okay, fifth root of, I need to write like this. This was like 5 root 6, so it's not correct to write it. So fifth root of 6, this value here 6 is called as RADICAND. It is called as 6 is called as a radicand, and this fifth root is there na, so this 5 here is called as order of surd. Okay students, 6 will be called as the radicand, and this fifth root, sixth root, seventh root, whatever root is there, if that value is non-terminating, non-recurring, so this 5 or n, it can be n, 5 or n and anything, it will be called as order of the surd. Very beautiful statement to remember. We even printed it out for you, that every surd is an irrational number. Every surd is an irrational number, but the vice versa is not true. Every irrational number is a surd? No. Every irrational number is not a surd. Okay. So now let's move on to some questions, means the operations on irrational number. Many a times you will be looking at question and you will feel that this is definitely an irrational number, and it will turn out to be a rational number. So I'll take some examples of it, like third cube root of 2 multiplied by cube root of 32. Okay, so here you see students, I'll take the sheet hand in hand. So what is the formula over here? Which formula is applied? What is the base? So I can even write this as 2 power 1 by 3 multiplied by 32 power 1 by 3. Why am I writing this? I have explained into the polynomial in one variable chapter, okay, into my that lecture. So any cube root, any root, nth root, any root can be written as cube root 2 can be written as 2 power 1 by 3. So cube root of 32 can be written as 32 power 1 by 3. You see the bases are different but the powers are same. since the bases are different and the powers are same, so what will happen over here, there can be two cases. We can do it into two ways. So you see that the bases are different. So this is a, so this is a power p multiplied by b power p. Okay, so what was it? AB power p, right? Now this can similarly be written into this way, that 2 into 32, right? That's what is happening. A into b, 2 into 32, and power is 1 by 3. Okay, now they have asked you to simplify it. So what you need to do, this 2 into 32 can be written as 2 into 32 can be written as 2 power 5, right students? And this is power 1 by 3. Okay, one by 3. Now what happened over here? This is 2 power 1 into 2 power 5. Since the bases are same and they're multiplied, the numbers are multiplied to each other, and here what is happening? Here this is having power 1 and this is having power 5. So according to our law that a power p into a power q, what happens? A power p plus q. So what will happen over here? 2 power p plus q, na? 5 plus 1 gives you 6, and overall power is 1 by 3. What is again happening over here? You will see that this is a power p to the power q, right? P is 6 and q is 6 and q is 1 by 3. So what happens? A power p q. So what will happen over here?